effective way to develop AI agents, one thing which I feel is that selecting the right agentic framework. So we saw that loop of agent calling LLM, and that whole loop which we saw, agent keeps on calling LLM till the time its purpose is achieved. Now we can write that code ourselves and make that agent happen. But is it worth our time? Certainly not. Why should we reinvent the wheel? There are agentic frameworks like Crew AI, LangGraph, Autogen, OpenAI Agents SDK, Google ADK, and quite a few others. I would say in today's world, there are hundreds of agentic frameworks now in the market, but these are probably the five popular ones which I listed over here. So yes, selecting the right agentic framework is very important. Uh, I have used Crew AI extensively. I've used OpenAI Agents SDK. I've used LangGraph to some extent. So far, I have my liking towards Crew AI, and everybody could have different kind of liking towards a framework. But my suggestion is pick up a framework that aligns with your project's needs and architectural goals. For example, building stateful LLM application, LangGraph is quite popular with that. No doubt we can build stateful applications with Crew AI as well, but LangGraph is more popular for that. So selecting the right agentic framework is something which I would say is the first right way to implement the agents. Now I'll draw an analogy. Now somebody, I guess Darshan talked about MCP tools. So before talking about MCP, let's talk about life before USB Type C. Before USB Type C came, this was the kind of ports which we had on the computers. Do you remember the era of 90s? If you were born by that time, or 2000, where there were so many ports, and eventually USB Type B came, and eventually USB Type C came, which is sort of becoming a de facto standard that, okay, this is the way we have to plug the devices. Every port should have USB Type C. I guess some country, or rather European Union, enforce that every device should have a USB Type C charger, something of that sort. What I mean to say is that having so many interfaces of uh, achieving a thing complicates the issue, and it's good to standardize. And we saw in our Amazon chatbot, or even in the bug fixing agent which I provided grep tool, list tool, and everybody would have their own implementation of grep tool, list tool, or Amazon chatbot. They could have its own implementation of that product tool, and it would complicate the issue in terms of it's an M cross N problem, in the sense that we would have M implementation of tools for N services, and there would be a maintenance nightmare in terms of managing those tools implementation for an organization or even across that. To just extend this analogy, Anthropic came up with Model Context Protocol, which is an open standard. It provides universal interface for tool creation and tool execution. So in a way, I could use Model Context Protocol to literally say, hey, what are the tools supported by a particular Model Context Protocol server called MCP server? I could fetch those tools, provide those tools to LLM, and then execute those tools based on the request from LLM. But I need not have that custom implementation of each tool. That's where the Model Context Protocol comes into the picture. For example, uh, I was using another day this Google Drive integration with Cloud Code. Now, Google Drive has created a MCP protocol, a MCP server implementation. So I had to just say to Cloud Code, connect to Google Drive MCP server. That's it. And Cloud Code was able to search all the tools supported by Google Drive MCP server and was able to give me those features. So in a way, what I'm trying to say is that this standardizes the tool creation, tool searching, and tool execution. I'll take a pause over here. Anybody has any question? Darshan, is your question answered? Okay, looks like,
Manpreet, I have one question.
yeah.
Okay, when you particularly said tool execution, right? What that means is this MCP server, if at all, if you are spawning, is that the place where the execution will happen, or it will happen in our local code base of agent? Let's say I have a tool where it will be called. Is that MCP is used just for constructing the tool prompt, for getting just the function name and let's say the parameters, or it's more than that? I mean, what the MCP servers, what offers behind the scenes? I mean, like where it should be used.
So if I could provide a summary around it, uh, let's say you have used OpenAPI?
Yes.
Okay. So any HTTP server, it provides, if let's say it's providing APIs, it could have its own documentation in the form of OpenAPI. And it would provide that Swagger file with the API documentation. Now, I could actually create an SDK based on that, and I could actually call those APIs from my side. And then ultimately the execution happens in the server, API server, which has exposed those open APIs.
Correct.
Similarly, we say MCP server has exposed some tools. And my agent, first thing what it does is that it fetches the list of tools implemented by that MCP server, provides those tools to the LLM. LLM says, okay, hey, I need to call this tool based on the context. Then agent says, okay, this tool is hosted by that MCP server. Then agent actually makes a call to that MCP server to execute that tool. So in a way, the implementation of that tool is in the MCP server, but the execution and the trigger happens from the agent or agentic framework, which is hosting that agent.
Right. Okay. Got it.
Sounds good? Okay. Okay, great, Darshan. Good to see your question is answered. I'll spend just a minute on this slide before we jump to the next set of sections. So you might have heard about this term called RAG, Retrieval Augmented Generation. Now, as well as short-term memory, long-term memory, and how agents could do personalization, ultimately, LLMs doesn't remember anything. LLMs don't know anything beyond the current request. That's what we discussed earlier as well. It is pure, dumb as well as intelligent, but transactional. Given an input, gives the output, doesn't remember anything. It's more like a goldfish. It doesn't remember anything beyond that particular, you could say, request. That's where sometimes we have to provide external knowledge to it. If it's a conversation history, we would like to provide it in the short-term memory, store it in short-term memory, provide it to LLM whenever the request goes. If it is something which is like personality of the user or some other thing which is to be stored across multiple sessions, we call it long-term memory. That could be also passed to the LLM as an input, which would lead to personalization of the responses coming from the agent. Or it could be, for example, your Amazon chatbot example. It had a agent for Amazon return policies. Now, return policies are, which is more like a document. So Amazon could have a bunch of PDF documents. It could give those PDF documents as a knowledge base to the agent. And there would be a mechanism called retrieval augmented generation. So where agent would be able to retrieve that data from that external knowledge whenever there is a, you could say, request coming from Amazon return policies, and then pass it to the LLM and say, hey, try to better refine your output based on these policies. So in a way, making LLMs more intelligent indirectly by providing that additional knowledge and memory to the LLMs.